Let's look at some problems related to calculating the probability of an event. First problem we're looking at here is problem number 4. It says 3 people are selected at random from a group of 5 men and 2 women. Okay, so we have 5 men, 2 women. We're selecting 3 of them at random. Find the probability that all 3 selected are men. So the event whose probability we want to calculate is the event that we would get all men in those 3 choices. Well, remember, the probability that some event occurs is the number of ways, the number of successes that particular event could occur, divided by the total number of ways that, in this case, choosing of 3 out of 7 could occur. What are the total number of outcomes? Of those outcomes, how many of them do we consider to be successes? And we form that fraction, and that's the probability that we would have that success. In this case, that we would get all men. So the total number of outcomes, we're choosing 3 out of 7. There's nothing in the problem that indicates any kind of order or different tasks or different assignments. So that's just going to be a combination. And when we're choosing, some of those choices will have all 3 men. Well, how many of them will? Well, if there are 5 men and you're choosing 3, that would be a combination of 5 taken 3 at a time. Now remember, when you calculate a combination, you first have to calculate the permutation. And divide by the factorial of the number that you are choosing. We're choosing 3, so it's permutation of 5 taken 3 at a time over 3 factorial. And counting the total number of outcomes would be a permutation of 7 taken 3 at a time over 3 factorial. The 3 factorials are just going to cancel for us. The permutation of 5 taken 3 at a time is 5 times 4 times 3. Permutation of 7 taken 3 at a time is 7 times 6 times 5. Let's see if we can simplify our arithmetic here. The 5s will cancel. 3 goes into 6 2 times. 2 goes into 4 2 times. We end up with 2/7, which as a decimal is 286 thousandths. So as a fraction, the probability is 2 out of 7. In other words, 2 times out of every 7 times you would make that choice, you would get all men. Or roughly, 28.6% of the time that would occur. So here's the probability that we would get all men. The second part of that problem said, find the probability that 2 men and 1 woman are selected. So we want the probability of 2 men and 1 woman. Well, we're still picking out 3 out of 7. So that remains the same, combination of 7 taken 3 at a time. But now we are choosing 2 from one set and 1 from another set. We're doing it to both sets, so that's a multiplication. So how many different ways could we get 2 men out of the 5 men? That would be a combination of 5 taken 2 at a time, times how many ways could we get 1 woman out of 2? Oh, remember, you're only choosing 1, so keep it simple. If you're choosing 1 woman out of 2 women, there are only 2 ways you could do that. So it doesn't have to be thought of as a combination. If you have 2 and you're choosing 1, there are only 2 ways you can do it. So when we convert those combinations to their respective permutations and factorials, so that's going to give us 5 times 4 over 2 times 1 times 2 over 7 times 6 times 5 over 3 times 2 times 1. Well, let's see, the 2's will cancel there, just giving us 20 in the numerator. 2 times 3 takes out the 6, leaving us 5 times 7 is 35, which reduces, we wanted to reduce it as a fraction. 5 goes into both of those. That would give us 4/7. So 4/7 of the time, which comes out to be just double the figure of the previous problem, 0.571. 4/7 of the time, or roughly 57% of the time, if you were to choose 3 people at random, out of these 7, you would expect to get 2 men and only 1 woman. Now, the last problem, the last part of this problem is an interesting question. It says, find the probability that all 3 selected are women. Well, if we're selecting 3, and you only have 2 women to choose from, the probability that all 3 of them would be women is 0. It can't happen. That kind of sounds like a trick question that maybe a math teacher might put on a test.